In this video lecture, I will discuss some of the examples of CFG construction. So first let's take this example. Construct a CFG for the language having any number of A's over the set sigma is equal to A. So as we know, the regular expression for the above language will be what? If it is any number of A means it will be the regular expression will be A star, right? So when star is 0 it will be epsilon, when star is 1 it will be single A, if star is 2 it will be 2A, if it is 3 it will be 3S, and so on. So this will be the regular expression. Now we have to write a CFG, and we know, okay, in CFG we have a grammar G which has 4 tuple V, T, P and S, where V is set of non-terminal, T is set of terminal, and P is the set of production, and S is the start symbol. Okay, and all the production we write in form of alpha to beta, and here alpha will be what? Some single non-terminal, and this alpha will be single non-terminal, and this beta will be terminal as well as non-terminal. So it will be combination of terminal and non-terminal. So V union T star means it can be all terminal, or it can be all non-terminal, or it can be a combination of terminal and non-terminal, and star means it can be even epsilon. Okay, and here we know that, okay, this V is set of non-terminal means usually we take capital letter symbols to represent non-terminal, small letter symbol, even digits will be nothing but the terminal. So here we have to construct a CFG, and which means and for the language which is having any number of A. So any number of A means my language will be what? The language generated by this CFG will be epsilon, single A, 2A, 3A's, okay, 4A's, and so on. So we have to write the production. Okay, so if I say S is the start symbol, and this A I want to repeat any number of time, and even epsilon I want to derive. Okay, so that means eps to epsilon there will be one production, and then this with this I will get this epsilon string. Okay, and then we write AS. So with this I will get any number of A. So here whatever grammar we are writing, okay, so that grammar will be nothing but this production rule. This is very important. This production rule is very important. So whatever production we are writing, we should be able to generate all the valid string of the language. So the language is given to us. We will first write all the valid string of that language, and then we will see the pattern and try to write the production like this. Okay, now with this we will see whether we are able to generate all the valid string of the language. Okay, so if I take S2 epsilon, I can derive epsilon. If I take S2 AS, okay, and in next step I take, okay, next step I replace this S by epsilon, so I will get 1A. Okay, or if I take S2 AS and next step again S I replace by AS. Okay, and then next step again I replace S by AS. So, and then to end the derivation at the end I will replace this S by epsilon. So I will get A. Okay, so 3A's. Like that, if I want 2A, so what I will do? Here itself I will end the derivation by replacing S by epsilon. If I want 1A, we have seen one, we will use if I say this is the production rule 1 and this is 2, so if I use 1 I get epsilon. If I use 2, with this I can get any number of A. So if I am using the production rule 1 time, I will get single A. If I am using the production rule 2 times, I will get 2 A's, like that. Every time I replace this S by AS, I will be getting any number of A. So this is my production. So how we will write the grammar? Okay, grammar we will say here non-terminal is nothing but capital S, and terminal is A, and this is production. Okay, this is production rule, and S is the start. S is the start symbol. Okay, so this is how we will write the grammar, and instead of writing two production like this, I can write, okay, S to epsilon or AS, like this also we can write. Okay, now let's take another example. Here in this example, we have to construct a CFG for the regular expression 0 plus 1 star. So 0 plus 1 star means this 0 plus 1 star is what? Any combination of 0 and 1 including null string. So whenever I say null string, one thing is clear. I will have one start symbol and epsilon will always come. And then I want any number of 0 or any number of 1. So just now we have seen for any number of a, what we wrote as. So now I want any number of 0, so I will write 0s. So with this I will get any number of 0. Now any number of 1 I want, I will write 1s. Okay, now we'll see with this, can I get all the valid string of the language? So valid string, so this is the production. So this is the production. Now we are saying it is capital S, and T we are saying it is 0 and 1, and S is the start symbol. Okay, now we will see whatever production we have written, is it correct or not. Okay, so now, okay, if I take S2 epsilon, I will get, okay, if I say the language is epsilon or single 0 or 1 or any number of 0 or any number of 1 or any combination of 0 and 1. Okay, anything. So S to epsilon if I take, okay, here itself my derivation will end, I will get epsilon. Now if I use S to 0s, okay, and in next step what I do, if I want, okay, if I want single 0, so here itself next step what I will do, I'll replace this S by epsilon and then it will be 0, I will get 0. If I am using S to 1s, okay, and I want to derive only 1, so next step I will replace S by epsilon, so here it will be 1, it will give me 1, so I can derive 1. Now if I want all zeros, any number of 0, so what I will do, okay, S to 0s, next step again this S I will replace by 0s, again next step I will replace this S by 0s. So like this any number of 0 I can get, and when I want to end the derivation I will just replace this S by epsilon. Okay, so if I replace S by epsilon I will get 3 0. Like that if I want 4 zeros, 5 zeros, or any number of 0 I can get. Similar way I can get any number of 1. Now if I want a combination of 0 and 1, okay, so combination of 0 and 1 means let me write the production once again here. So S2 epsilon 0s and 1s. Okay, now if I want suppose 0 1 0 1 0 1, this is what a combination of 0 and 1. So now what I will do, okay, S2 it starts with 0, I'll use 0s. Next after 0 I want 1, so next step I will replace this S by 1s. Next after S1 I want 0, so I will replace this S by 0s again, 0 1 0s, and then again after 0 I want 1, so next step I will replace 0 1 0 1s, and then again I want after 1 I want 0, so I'll replace this S by 0 1 0 1 0s, and then after 0 again I want 1, so next step S I will replace by 1s, so 0 1 0 1 0 1s. And whenever I want to stop the derivation, I will just replace this by epsilon. So 0 1 0 1 0 1 0 1 0 1 0 1. Here I want to stop, I will replace this as by epsilon, so I'll get 0 1 0 1 0 1. Like that any combination of 1 and 0, if I say 1 1 1 and 0 0 0, this is also valid string. So what I will be doing, I'll be first because my string starts with 1, I'll be using this production first, S2 1s, and then next step again after 1 I want 1 only, so again this S I will replace by 1 only, 1s, and then again after this 1 2 1 again third symbol is also 1, so again I will be replacing this S by 1s only, and then after 3 ones I want 3 zeros, so that means next step I will replace this S by 0s, so then I will take, okay, 1 1 1 0s, and then again after first 0 I want one more 0, so it will be 1 1 1 0 0s, and then again I want one more 0, so again I'll replace this S by 0 s only, and then end of the input I want to stop the derivation, so I'll replace this s by epsilon. So 1 1 1 0 0 0. So whenever we write a context free grammar, we have to keep in mind we should have some stopping condition, some terminal should be there or epsilon should be there. Suppose if I just write s to 1s or 0s and I am not writing epsilon, so we have to somewhere stop the derivation, because at the end I should get the string which has only terminals, which it should not have non-terminals. So here if I say okay, this is the derivation, so I have to replace this capital S by some terminal symbol. So that terminal means for any production there should be a terminal symbol or epsilon that is required to stop the derivation. So this is how we will write the context free grammar. Okay, let's take one last example. Here if I say okay, construct a CFG for the language a power n b power 2n, okay, where n is greater than and equal to 1. So this is the language. For this we have to construct a CFG. So construct a CFG, okay, for L is equal to a power n b power 2n. So a power n b power 2n, what do you mean by a power n b power 2n? Means I will first write all the valid string of the language whenever we want to write the grammar. Okay, so means n is greater than or equal to 1 means at least one n value will be 1. So if n is 1, a is 1, I should have 2 b. So a b b, or if a is 2, I should have 4 b's. When a is 3, there will be 6 b's, and so on. Okay, so then we have to write a grammar for this. So what is my minimum string? It is ABB. So whatever S we are writing, okay, so we have to write ABB. So this is the minimum string that we are going to derive from this language. Okay, and then we have to, for other string, to derive all other string, I have to write the rule. So we say whenever one A comes, there will be 2 B's. Okay, so this is the rule we are writing. With this, if I say okay, I want to derive only ABB, so S will be replaced by ABB, we will derive this. Now any other string I want to derive, okay, so if I take S to ASBB, so if I want to okay 2 A's and 3 B, so what I'll do, this S next step I will replace by ABB, so it will be ABB, and there are already 2 B's, so I'll get 2A 4 B's. Okay, now if I want 3A and 6 B's, so what I will do here itself, instead of replacing this S by ABB, we will again replace this S by ASBB. So this S by ASBB, there were 2 B's already, and then see here there are 4 B's, 2 A's, and then I want to stop the derivation, so this S at the end I will replace by ABB, so ABB, and 4 B's were already there. So this is how we will be using this rule again and again to get the all other string. Okay, so this is how we write the context free grammar. Hope you have understood the concept. Thank you for watching.